You're welcome to another episode on nuclear chemistry, also known as radionuclear chemistry. But for this particular episode, I want to describe the two kinds of radioactivity, the two types of radioactivity in chemistry. So we have the natural radioactivity, then we have the artificial, or you can call it the induced radioactivity. Is either it is artificial or it is what? Induced. So these are the two kind of radioactivity we have. Oh, let me explain the first one, natural radioactivity. Natural radioactivity is the one I'll be explaining from the beginning of the video to this very extent, whereby the nuclide is unstable. So if it's unstable, you have to disintegrate. It occurs spontaneously. It's natural. It's a spontaneous phenomenon, like a waterfall. I mean, spring water, rock water, those kind of, that's a spontaneous. The way we live our life is spontaneous. Like this particular video now is I can say it's spontaneous. So to an extent, natural radioactivity is spontaneous. The nuclide will definitely disintegrate. It can start the process today, it can end in next 10 years, next 20 years, next 30 years, talking about half-life and the rest. So but please take note, natural radioactivity occurs on its own. It doesn't need anything. So it's a natural process. The nuclide is already unstable, so the process is going to continue like that till the process is going to disintegrate till it attains stability. The nuclide to attain stability. So that's for natural radioactivity. But this artificial radioactivity, on the induced radioactivity, we already know that this thing is stable, but because of human effect, because of what we want from that, what we want for that particular nuclide, we are going to subject that nuclide again to radioactivity. We are going to force that nuclide to form other radioactive elements, which is artificial. We are going to induce it for you to form other radioactive elements. It's not occurring naturally, it's man-made. You are the one forcing it. Like this one now, it occurs naturally, it's just there. It's going to take place on its own accord, not you telling this reaction that you must take place. So take note of the difference between natural radioactivity and then the artificial radioactivity. So what's the difference between natural radioactivity and artificial radioactivity? So please take note, the emission of radiation is due to self-disintegration. So for natural radioactivity, this disintegration itself is natural, it occurs in its own. So it's talking about self, so it doesn't involve any other thing. But for this one here, it is induced by human. So we have to start the radioactivity for we are needed for this kind of reaction. So but for this very one now, it occurs on its own, doesn't need Guido Academy to be there to carry out the titration, to carry out the radioactive process. But for this very one now, I need to be there. So on that thing again, uncontrollable disintegration. Now you cannot actually control the disintegration, like what I told you before. You will move from the parent nuclide to daughter nuclide to granddaughter, great granddaughter, great granddaughter, great granddaughter, great granddaughter, so until you attain stability. So that is for natural radioactivity. But for artificial radioactivity, you can actually control it. Remember, you are the one that initiated the radioactivity, so that's to say you can actually control that radioactivity. Then the next one, it is spontaneous, it is not spontaneous. Natural occurs on its own, but artificial, it doesn't occur on its own. And that's to say it can actually be reversed. So anything that doesn't occur on its own, to an extent, it can be reversed. It is reversible. Then the last one, it involves the emitted particles. They are alpha, beta, and the gamma. But for this one, we have neutron, positron, etc. There are other particles. These are just the major ones. So another thing again I want you to take note of, if you see any reaction that involve 85, the proton number is above 85, just know it's above 85, just know that it is a natural radioactivity. But anyone that is 85, that is below 85, just know that it is artificial radioactivity. So this is another major difference. If you see any reaction at all, let me just give you one so that let's check if truly it's natural radioactivity or it is artificial radioactivity. Please take note, below 85 is artificial, above 85 is natural radioactivity. Let me just give you one example to test if truly you are following what I'm saying. Just a little correction before I continue. It's supposed to be 83, not 85. Above 83, then below 83. So it's not 85. Now, if you look at this one is actually below it. Please, this one doesn't really work for all. To an extent, this is just a clue. This is just a clue. It doesn't work for all radioactive elements and all that. Just put this in the back of your mind. But if you really want to check if this reaction is it radioactive, this very one here is it radioactive, this very one here is it radioactive, this one here is it radioactive, what will happen is that I'm going to explain. You don't even need to go through all this 83 stuff. I've given you top differences already. Some person will say this one is 60, below 83. Natural radioactivity, artificial radioactivity, artificial radioactivity, artificial radioactivity, artificial, above, natural. To an extent you are correct, but you are still wrong. Now, how do you mostly detect if it is natural or artificial? What is the radioactive particle that is emitted? Beta. Here is what? Beta. Beta is what? Since you are emitting beta particle, that's a what? A natural radioactivity. This very one here, what are you emitting? A proton. So you are emitting a proton. Proton is more of a 1 hydrogen. If you calculate, you are going to get the answer. This plus this, that will give us 31. This plus this give us 31. Here will give us 15. Here will give us 15. So that's for that. So this one here is an artificial radioactivity because of the particle that is emitted, not because of 83 or below 83. Then this one here again, let's check. Is it really natural or artificial? Remember, this N stands for neutron. Neutrons talk about 1 and 0. So let's check. 9 plus 4 will give us 13. 12 plus 1, 13. 4 plus 2, 6. 6 plus 0, 6. So that's for that. Now let's check this. Uranium to thorium, is that a natural radioactivity or is an artificial radioactivity? Please take note. Natural is spontaneous, artificial is what is induced. An example of particles that are emitted during the natural radioactivity, which is the one that occurs naturally, we have alpha, we have beta, we have gamma, and for artificial we have the neutron, the protium, and the rest. So that's for that. So if you have watched the video from the beginning to this very end, I believe that this question should not be a problem. Please drop your answer in the comment section. I hope to get a review regarding all the video we have dropped so far. If you have any question regarding anything at all, feel free to drop in the comment section. I'll be there to attend to that, or I will create a video to that effect as well. Thanks for watching. Stay blessed. I hope to see you in the next video, and please share the videos to others. Please share the videos to others. I'm begging you, share the videos to others so that YouTube can get my account recommended. Thanks for watching. Stay blessed.